Hey, what is up, YouTube? This is Dirty Math, back from a very long break. I mean, this has been what, 3, 4 years? I can't really even fathom how long it's been, but I'm back and I'm very happy to see you guys again and get to teach, which is what I live for. Today we have multiple integrals. We are gonna be talking about a specific problem here, and I'm going to show you a smart substitution, which one can do in order to make it quite a bit easier to calculate. But without further ado, uh, make sure to like and subscribe, or actually, let's not do that. I will earn your subscription. So, yeah, I'm sure you'll subscribe at the end of this lecture. But please make sure to comment and tell me how you've been because I really want to know. It's been years now. But without further ado, let's get right into it. So we have this problem here. Cindy is a struggling sex worker that works under the ruthless pimp Cornelius Kashmir Jones. Lately, Kashmir has taken on an increasingly aggressive attitude towards Cindy. She must now get out of his control. Kashmir has stated that he'll let her go if she can pay him $7,000 by the end of the year. Right now, she is unable to put away any money to her savings account. The plan is to get a pair of breast implants. According to our calculations, these implants could yield an extra 14 grand in earnings by the end of the year, which she could obviously save. However, the implants likely cost a lot. She must calculate how much they would cost, and she knows the following information. So there are two implants. The implants are bound by the ellipsoid of this shape, which I will go into later. The density of the silicone is 1.1 grams per cubic centimeter, and the cost of the silicone is $4 per gram. Question is it possible for Cindy to save up to $7,000 given the extra earnings of $14,000 and the price of the two implants, which she will have to pay for? Well, let's get into it and see. So, we have this shape, which is bound by this x squared y squared over 81 plus z squared over, what was it, 25, right? Yup. Smaller than or equal to 1. Now this shape will take on the form looking something like this. This is an ellipsoid, as we stated, so we'll have the x, y, and z axis. We'll have some of these just to mark sort of the direction here. And what we know here is 81 equal to 9 squared, 25 equals 5 squared. So we'll set these bounds here, 9, 9, 5, and we'll get this shape going around like this sort of. I guess I'll make it like that. And, oop. Well, as you can see, I'm not the best painter in the world, but you get the point. It's an ellipse with its its I guess its radius in the xy plane equal to 9 and the radius in the z axis or along the z axis equal to 5. What we will do is make a smart substitution where we get these vectors uh, sorry, where we get these vectors u, v, and w, and which will get us an equation where we have um, a sphere with the radius 1 in all directions. And this will be a linear transformation. This transformation is the transformation where for our value of u, if we put it into x, we should get simply u squared. And how do we get that? Because what our goal is to get u squared plus v squared plus w squared less than or equal to 1, because this would be a sphere. And right now we have an ellipsoid here. So the substitution we need to make is actually this one. We'll have x equal to u, and then, of course, 9 times 9, since when we square this u times 9, we'll get 9 squared, which, as we can see, 9 squared is in the denominator here, so we'll get, as you'll see, x squared over 81. If we put u times 9 in there, we'll get u squared times 81, and that'll give us u squared. So x equals, I'll write it like this, x equals 9u, v equals 9, y equals 9v, and z equals 5w. And this will be our substitution, giving us a transformation, or this will give us a sphere, as I've stated. And the good thing about this is a sphere's volume is very equal to calculate. And as we see here, we have a radius equal to 1. So the sphere will have a volume of, well, the sphere's volume is 4 over 3 pi times radius cubed. And radius was equal to 1. So we'll just get 4 pi over 3. Now this will be the volume of the sphere. All we need to do is calculate the determinant of the transformation we've done, this one, and we'll just multiply this number by the determinant and we'll get the volume. So just quickly, instead of calculating this integral where we have d, we have what? We have dx1 times dx dy dz, or actually we would put in the density, but at this in this situation the density is constant, so it doesn't really matter. But I think it was 1.1, but whatever. And where d is given by the following, so we have x, y, z are 3 given by x squared over 81 plus y squared over. Instead, we can simply calculate if we just calculate the determinant of the transformation, namely what we call the Jacobian determinant, we multiply that by the volume of the sphere. So we'll have 4 pi over 3 times the Jacobian determinant, which I'll just call JD. I'll just call it that this time. We'll get the total volume, and then we'll multiply by density, of course, to get the total density, or total weight, sorry. But let's go to the Jacobian determinant, and that'll of course be the determinant of all the partial derivatives with respect to all yeah, you get what I mean. dv and dx dw, all the partial derivatives of each variable with respect to each of the transformed variables. So we'll have dy here, du, you get the gist of it. It'll end at dz dw. But what we know is, since if we just take a look at this transformation, we know that the partial derivatives will actually be 0 for when you take the ones that are not, I mean, each of our variables x, y, and z are simply bound to one of these transformed variables. So you don't really need to. I mean, you will pretty quickly see that the determinant will simply be of the matrix 9, 9, 5, and then just zeros like so. And that determinant will obviously be, since we have a not if since we have zeros here, the rest will just be zero. So we'll simply just get the determinant of 9 times this determinant, which will be 950. And that'll of course be 9 times 9 times 5. Giving us a total of, what is that? 405, I believe. Funny thing, I bench 405. I'm not that strong. But we have this sort of, this is the increase in volume which we get per unit of volume, so to speak. So quite a bit, or yeah, what this represents is each unit of volume in our previous system is equal to 405 units of volume in our second system. So we get the total volume to be equal to 405 times, 405 times, what was it? Let me, 4 over 3 pi, of course. 4 over 3 pi. And then we can even, now we can calculate the total weight. So the total mass will be equal to 405 times 4 times pi over 3 times 1.1. And the total cost will be equal to mass times cost per mass, which we know was equal to mass times $4 per gram. So we'll get $4 per gram times, we had 405 gram here. 405 times 4 times pi, right? Yep, times 1.1 over 3 grams here, of course, which will be equal to, what's that? So this is going to be quite a bit here. So it'll be what, 135 times 16 times 1.1 times pi dollars, I believe, which will be equal to quite a big number, but we'll just approximate it here. So we'll say, I guess, I suppose we'll just, actually, I'm gonna just plug this into the calculator here. We'll see. So we have 135 times 16 times 1.1 times pi. I'll just say 3.14. That's gonna be, wow. I just put some random numbers, but this is actually surprisingly close to what this is a sort of edging number. So $7,460 approximately.
And as you'll see here, I forget to multiply the 7,460 or whatever it is by 2, which would be the pricing for the 2 implants. But the answer remains no. She will not be able to purchase the implants. But yeah, that's about it. And well, I hope you enjoyed this lecture. I'll be making sure to post more frequently now that I'm back. It's well, it's been a pleasure, and I hope to see you again. Have a great week. Bye.